This is Japan's Shinkansen, the bullet train.
Born from the engineering efforts after World War II, it can reach top speeds of 200 miles per hour, 320 kilometers per hour. Over the past half-century, it has transported over 10 billion passengers and helped Japan grow into the world's third-largest economy.
But Japan didn't stop there. To further shorten travel time between Tokyo and Osaka, Japan has invested tens of billions of dollars to build the world's fastest passenger railway, the Chuo Shinkansen Maglev Line.
This train can exceed 310 miles per hour, 500 kilometers per hour, cutting the Tokyo-Osaka trip to roughly 1 hour. Yet, more than a decade after the project began, this highly ambitious megaproject has been mired in delays, skyrocketing costs, and environmental controversies. Some see it as a project that could once again transform Japan's future. Others fear it could become the most expensive gamble in Japanese history. So why is Japan determined to build this maglev line? Will it become a second Shinkansen miracle, or a super expensive project that never pays off? Japan has long been a leader in rail transport. As early as 1959, it began constructing the Tokaido Shinkansen, connecting Tokyo and Osaka, becoming the first country in the world to build a high-speed railway. At the time, not only within Japan but across the globe, many questioned the massive investment. With rapid development of aviation and highways, some argued that rail travel was a thing of the past and high-speed rail had no future. Despite doubts, the Tokaido Shinkansen officially opened in October 1964, in time for the Tokyo Olympics.
It cut travel time between Tokyo and Osaka from nearly 7 hours to under 4.
The line was an immediate success, carrying over 100 million passengers within its first 3 years.
Today, the Shinkansen is one of Japan's most important transportation systems.
If the Chuo Shinkansen is completed, the Tokyo-Osaka trip will take only about an hour, more than half the current travel time. The key to this breakthrough is maglev technology. The train's operational speed is 310 miles per hour, 500 kilometers per hour, and during a test in 2015, it set a world record of 375 miles per hour, 603 kilometers per hour. Industry experts generally agree that conventional high-speed trains cannot continue increasing speed significantly.
As velocity rises, friction between wheels and rails, vibration, and noise all increase dramatically. So Japanese engineers turned to a long-standing technology, magnetic levitation. In fact, the concept of maglev dates back to the early 20th century. The world's first commercial high-speed maglev line opened in Shanghai in 2004. Japan, however, opted for the technically more challenging superconducting maglev. Superconducting magnets are cooled to near liquid nitrogen temperatures, allowing the train to levitate about 4 inches (10 centimeters) above the track. Once the train reaches sufficient speed, it lifts off its wheels entirely, propelled forward by magnetic forces. The coils in the track provide both levitation and propulsion. Without wheels, the train can reach speeds far beyond conventional high-speed rail. In 2015, Japan's maglev set a record of 375 miles per hour, 603 kilometers per hour. The Chuo Shinkansen's commercial operation is expected to run at 310 miles per hour, 500 kilometers per hour. However, setting records does not guarantee smooth project progress. Since officially starting construction in 2014, the line has faced multiple delays. Originally, the Tokyo-Shimoku section was planned to open in 2027. But due to environmental disputes, construction challenges, and cost issues, that target is no longer realistic. The strongest opposition came in Yamanashi Prefecture. The line must pass through the Southern Alps, and locals fear tunnel construction could harm the river ecosystem, a vital source of drinking water. While environmental reports claim risks are manageable, local authorities remain unconvinced. Years of debate have contributed to the delays. Beyond environmental concerns, the project faces enormous costs. The Chuo Shinkansen spans about 177 miles, 285 kilometers, with over 90% underground, including roughly 159 miles, 256 kilometers, of tunnels cutting through complex mountains and fault zones. To achieve ultra-high speeds, the track must remain as straight as possible, requiring extensive deep tunnels. This has made it one of Japan's most complex and expensive railway projects ever, with costs soaring from an initial estimate of $13.7 billion to over $64 billion, a staggering sum even for Japan. As costs rise, domestic criticism of the project's value has grown. Maglev trains also have drawbacks. Construction and operating costs are far higher than traditional high-speed rail. Energy consumption is greater. Passenger capacity may not surpass mature Shinkansen trains. Frequency is limited. Conventional Shinkansen can dispatch trains every 3 minutes. Maglev tracks cannot match that. In other words, faster speeds do not automatically mean higher transport efficiency.
Meanwhile, global high-speed rail competition has shifted. Over half a century ago, Japan pioneered high-speed rail.
Today, China has the largest high-speed rail network in the world, and by 2026 will maintain the top global mileage share. China is also developing maglev technology.
In July 2021, a Chinese maglev test train reached 373 miles per hour, 600 kilometers per hour, nearly matching Japan's record.
In theory, a Beijing to Shanghai trip could take just 3.5 hours, shorter than a flight. So why does Japan continue to push this project? The answer may be more than just speed.
If completed, the Chua Shinkansen will strengthen links between Tokyo, Nagoya, and Osaka, potentially compressing cities hundreds of miles apart into a 1-hour living zone. Talent, capital, and industry would circulate more efficiently.
For Japan, this is a national strategy spanning decades. Similar development models are underway worldwide.
China is expanding city clusters. The US is strengthening connections along the Northeast Corridor. Europe is connecting core economic regions.
Increasingly, competition may not just be between cities, it could be between megaregions.
Over 60 years ago, few believed Japan could build the world's first high-speed railway. But the Shinkansen changed Japan and reshaped global rail development. Now, Japan is betting on a faster, more expensive, and more controversial technology.
Will it usher in a new era like the original Shinkansen, or become an expensive experiment in ultra-high-speed rail? The answer will only become clear when the Chua Shinkansen finally begins operations.